Good morning, everyone. This is B. Ramarao from Government Polytechnic College, Station Ganpur. Today, we discuss about electronic configuration and orbitals. These topics about diploma first year students, first semester, topic electronic configuration and orbitals. Electronic configuration and orbitals. Objectives about these topics. On the completion of this period, you would be able to know. On the completion of this period, you would be able to know about electronic configuration. This electronic configuration depends on Aubau's principle, Wundt's rule, and Pauli's principle. These three principles are explained about arrangement of electrons in an orbit. The electronic configuration depends on Aubau's principle, Wundt's rule, Pauli's principle. And what is orbital? What are the shapes of orbitals? Finally, we discuss difference between orbit and orbital. Difference between orbit and orbital. In this hour, we discuss electronic configuration of an atom. This electronic configuration explain different various types of theories. Those are Aubau's principle, Pauli's principle, Wundt's rule. These three rules are explained arrangement of electron in an orbits. And also different types of orbitals are available: s orbital, p orbital, d and f orbital. Differences between orbit and orbitals. Orbit and orbitals. What is electronic configuration? Electronic configuration or electron configuration. A detailed way of showing the order in which electrons fill in around the nucleus. The configuration means the distribution or arrangement of electrons. Arrangement of electrons in various orbitals of an atom is called electronic configuration. The distribution of electrons in various orbitals of an atom is called electronic configuration. The detailed way of showing the order in which electron filling around the nucleus. Knowledge of electron configuration is very important. This is because various properties like metallic property, magnetic, conductivity, chemical properties of elements mostly depends on electronic configuration. The arrangement of elements in the modern periodic table also based on electronic configuration. So, the following rules are proposed to distributed and arrangement the electrons present in atom of various elements. The electronic configuration means the available electrons arrangement in various orbitals of an atom is called electronic configuration. The distribution of electrons in various available orbitals in an atom, that means in ground state, is called electronic configuration. The arrangement of electrons available orbitals is called electronic configuration. These electronic configuration explain about three rules are there. These three rules are Abbo's principle, Pauli's exclusion principle, and Wundt's rule. Abbo's principle, Wundt's rule, Pauli's exclusion principle. The arrangement of electrons depends on three principles. Those are Abbo's principle, Pauli's exclusion principle, Wundt's rule. Abbo's principle. What is Abbo? Electrons are added. Electrons are added in orbitals in order to increasing order of energy levels. What is above? Above means building up. How to build? Now ground level to higher level. So the Abbo's principle states that electrons enter into the orbitals in the increasing order of their energy levels. This means that electrons occupy the lowest energy orbitals first, then after enter into higher energy orbitals. So, this theory explain about the electron enter into orbital first of all ground state, then after increasing order of energy levels of orbitals. According to this theory, the electrons enter into the orbitals in the increasing order of their energies. That means electron enter into lower energetic orbital before enter into the higher energetic orbital. Electrons are filled progressively in the increasing order of their energies. How do you calculate the energy of orbitals? The energy of orbitals depends on principal quantum number n value and azimuthal quantum number L value. The principle is useful in the calculation of relative energies of different orbitals on the basis of n plus L value. N plus L value. Greater the n plus L value, more will be the energy of orbitals. If n plus L value is same for two orbitals, the orbital with lower n value has lower energetic orbitals. Second one, Pauli's principle. What is Pauli's? No two electrons. No two electrons in an atom can have same values for four quantum numbers. No two electrons in the same orbital can have the same values of four quantum numbers. That means the principal quantum number n, azimuthal quantum number L, magnetic quantum number m, and spin quantum number s. In this four quantum number of two electrons cannot have same. One of the quantum number are different. All the four quantum numbers are different. But no two electrons in an atom can have same values for four quantum numbers. Third one, Wundt's rule. Electrons occupy equal energy orbitals. Equal energy orbital means degenerate orbitals. What is degenerate? The orbital having same energy orbitals are called degenerate orbitals. P orbitals have 3 degenerate orbitals. D orbital have 5 degenerate orbitals. F orbital have 7 degenerate orbitals are available. So, the electron occupy equal energy orbitals px, py and pz. These three p orbitals have same energy, so that the maximum number of unpaired electrons results. Whenever degenerate orbitals are available for electrons, the pairing of electrons takes place only after all orbitals are filled with one electron each. Whenever degenerate orbitals are available for electrons, the pairing of electrons takes place only after all orbitals are filled with one electron each. These three rules are explained about filling of electrons in an orbitals. S orbital, it have only one orbital. This one orbital maximum number of electrons 2. P orbital have 3 degenerate orbitals px, py, pz. These p orbital present maximum number of electrons 6 electrons. D orbital have 5 degenerate orbitals. 5 degenerate orbitals are available. dxy, dyz, dzx, dx square minus y square and dz square. These 5 degenerate orbitals are available in d orbital. F orbital have 7 degenerate orbitals. These F orbital present maximum number of electrons 14 electrons. D orbital present maximum number of electrons 10 electrons. P orbital have maximum number of electrons 6 electrons. S orbital have maximum number of electrons 2 electrons. According to Abbo's principle, the orbital present electrons. These electrons enter into the orbitals in the increasing order of their energy. These energy of orbitals can be calculated by using n plus L value. Orbitals with lowest value of n plus L are filled fast. So in case of n plus L value is lower value, that is lower energetic orbital, this orbital electron first enter into lower energetic orbital. Let's consider 3d and 4s orbital. This 3d orbital n value is 3, L value is 2. So 3d orbital n plus L value 3 plus 2 is equal to 5. 4s orbital n plus L value is 4s orbital n value is 4 and L value is 0. Then n plus L value of 4s orbital 4 plus 0, that is 4. 4s orbital n plus L value is 4. 3d orbital n plus L value is 5. Hence 4s orbital has lower energy than 3d orbital. 4s orbital has lower energy than 3d orbital because n plus L value is lower value. So electron first filled in 4s orbital, then after enter into 3d orbital. So 4s and 3d, these two different orbital. In these two different orbital, n plus L value is lower value of 4s orbital. This 4s orbital first fill completely, then after enter into 3d orbital. This one is first condition of Abbo's principle. These two different orbitals, which orbital n plus L value is lower, that orbital enter into first, then after enter into higher energetic orbital. If two orbitals have same value, if two orbitals have same values for n plus L value, then electron will go in the orbital which have lower value of n. Lower value of n. If two orbitals of same value of n plus L, then electron will go in the orbital which have lowest value of n. For example, 2p and 3s. 2p and 3s. 2p and 3s. These 2p orbital n plus L value. 2p orbital n value is 2, L value is 1. Then 2p orbital n plus L value 2 plus 1 is equal to 3. 2p orbital n plus L value is 3. 3s orbital n plus L value, 3s orbital n is equal to 3, L is equal to 0. Then 3s orbital n plus L value, n plus L value, 3 plus 0, that is equal to 3. 2p orbital n plus L value is 3 and 3s orbital n plus L value also 3. These two different orbitals n plus L values are same. N plus L value same. If the n plus L value is same for two orbitals, the orbital which lower n value has lower energetic orbital. Then 2p and 3s orbital n plus L value is 3. Then electron enter into first 2p orbital. This 2p orbital n value is lower value than 3s orbital. So electron first enter into 2p orbital, then after enter into 3s orbital. If the n plus l value is same for two orbitals, the orbital which have low n value has lower energetic orbital. This energy of orbitals, relative energies of orbital can also obtained from Euler diagram. This Euler diagram can explain energy levels of orbitals. 1s, 2s, 2p, 3s, 3p, 3d, 4s. These different orbitals energies can be calculated by a given increasing order of energy levels of orbital. 1s less than 2s, 2s less than energy than 2p, 2p less energy than 3s, 3s less energy than 3p, 3p less energy than 4s, 4s less energy than 3d. So electron first enter into 4s, then after enter into 3d. 3d less energy than 4p, 4p less energy than 5s. Electron first enter into 5p, then after enter into 4p, then after enter into 5s. 1s orbital has lowest n plus l value. So filling of electrons starts from 1s. 1s orbital lowest value of n plus l value. So filling of electrons start from 1s orbital. 1s orbital n is equal to 1, l value is 0, then n plus l value is 1. So electron first enter into 1s orbital. This 1s orbital lowest n plus l value. So electron first enter into 1s orbital. 2p and 3s. 2p and 3s. 2p and 3s have same n plus lambda or l value. Lambda or l means azimuthal quantum number value. But 2p is filled first due to lowest n value. 2p and 3s. 2p n plus l value 2 plus 1 that is equal 3. 3s orbital n value 3, l value 0, then 3s orbital n plus l value is equal 3 plus 0 that is equal 3. 2p and 3s orbital n plus l values are same, but 2p is filled first due to lower n value. 2p and 3s have same n plus l value, but 2p is filled first due to lower n value. Lower n value. As per rule, 4s is filled before 3d due to lower n plus lambda or l value. Four s orbital n plus l value 4 plus 0 that is equal 4. 4s orbital n value 4, l value 0 that is equal to n plus l is equal to 4 plus 0 that is equal to 4. 3d orbital n value is 3, d orbital l value is 2, therefore n plus l is equal to 3 plus 2 that is equal to 5. 3d orbital n plus l value is 5, 4s orbital n plus l value is 4. Then electron first enter into 4s orbital, then after enter into 3d orbital due to n plus l value. This n plus l value is lower value of 4s orbital. First enter into electron, then after enter into 3D orbitals. Abbott's principle, energy levels of orbitals. This orbital diagram is called Euler diagram. Electron first enter into 1s, then after 2s, 2p, 3s, 3p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p, 8s. These are increasing energy levels of orbitals explained by Euler diagram. Pauli's exclusion principle. An orbital can hold a maximum of 2 electrons. To occupy the same orbital, 2 electrons must spin in opposite direction. Helium atomic number is 2. These 2 electrons present in s orbital. These s orbital present 1s2. N, L, M, S values. First electron N value is 1, L0, M0. Spin quantum number plus 1 by 2. Second electron 4 quantum number values. N value is 1, L value 0, M0. S value is minus 1 by 2. For every set of electrons in an orbital, spin quantum number is always different. So, according to Pauli's, no 2 electrons can have same values for 4 quantum numbers. These 2 electrons present in helium. The electrons in an atom may have same N, L and M values but differ in spin quantum number. Helium N values are same, L value same, M value same, but spin quantum number first electron plus half and second electron minus half. In an orbitals of one electron has plus 1 by 2 and other has minus 1 by 2. Once within a sub-level, place 1 electron per orbitals before pairing them. Empty bus seat rule. These 4 electrons filled in p orbitals, px, py, pz. First filled, each orbital contains 1 electron, then after pairing of 4th electron. What is orbital? What is orbital? Orbital. An atomic orbital is defined as the region in space around the nucleus in which the probability of finding of electron is maximum. The probability of finding of electron is maximum is called orbital. The region around the nucleus where the probability of finding an electron is maximum is called orbital. An atomic orbital is defined as the region in space around the nucleus in which the probability of finding the electron is maximum. The probability of electron in an orbital is 95%. A plane of orbital at which the probability of finding electron is 0 is called nodal plane. Where the finding probability is 0 is called nodal plane. What is orbital? The region around the nucleus where the finding probability is maximum. An electron is called orbital. Shapes around the nucleus of orbitals. These orbitals of s orbital, p orbital, d orbital and f orbital. The shape of s orbital. Spherical in shape. These s orbital n values are 1, 2, 3, 4, l values 0, m values also 0. No degenerate orbitals are available in s orbital. The space around the nucleus, the one tells you that the electron is in the orbital closest to the nucleus. S tells you about the shape of orbitals. 2s orbital. Similarly to 1s, except the electron is most likely in the region further from the nucleus. 2s orbital. P orbital. At the first energy level, there is only the 1s orbital. After the second energy level, there is 2p orbital. Look like dumbbell shape in the three directions. P orbital. These p orbitals present in dumbbell shape. These p orbitals have three orientation. These three orientation orbitals are px, py and pz. These p orbital n values are 2, 3, 4. L values are 1, m values are -1, 0, +1. So it have three orientations are available in p orbitals. See here three degenerate orbitals of px, py and pz. The three p orbitals are px, py, pz. These orbital lobes along the x-axis is called px orbital. Orbital lobe along the y-axis is called py orbital. Orbital lobe along the pz orbital is called z-axis is called pz orbitals. D orbital. These d orbital have double dumbbell in shape. These d orbital have 5 orientation. These 5 orientation orbitals are dxy, dyz, dzx, dx square minus y square and dz square. For d orbital, L value is 2. Therefore, the angular momentum of an electron for d orbital is not 0. For L value is 2, the magnetic quantum number of m values should have 5 different values are -2, -1, 0, +1, +2. Accordingly, there are 5 different shape orientations for d orbitals. 5 degenerate orbitals are available in d orbitals: -2, -1, 0, +1, +2. These d orbital are divided into two sets: orbital in which lobe orientation between axes are dxy, dyz, dzx. Orbital in which lobe orientation along with the axis. There are dxy minus y square and dz square. See here d orbital shapes: dxy, dyz, dzx, orbital lobes in between the axes. dxy orbital lobes between x and y axis. dyz orbital lobes in between y and z orbital. dzx orbital lobes in between x and z orbital. dx square minus y square and dz square orbital lobes along the x and y and z axis. Difference between orbit and orbital. Orbit. It is a circular path of electron around the nucleus. Orbit. It is a circular path of electron around the nucleus. Orbital. It is a region around the nucleus where the finding probability is maximum, is called orbital. Orbit. It is circular in shape. Orbital have different in shape. It is only one shape, that is circular shape around the nucleus. Orbital have different shapes: p orbital dumbbell shape, d orbital double dumbbell shape, s orbital in spherical shape. It is a two-dimensional representation. This orbit depends on only two-dimensional, that is x and y axis. It is a three-dimensional representation. This orbital depends on x, y and z axis. X, y, z axis. It is a circular path of electron around the nucleus, is called orbit. Where the electron finding probability maximum around the nucleus is called orbital. This orbit present in circular shape. Orbitals are present in different shapes: s orbital in spherical shape, p orbital in dumbbell shape, d orbital in double dumbbell shape. This orbit depends on only two axes, x and y. Orbital depends x, y and z axis. Next one, the maximum number of electrons present in orbit is 2n square. 2n square. N means principal quantum number 1, 2, 3, 4, so on. If first cell n is equal to 1, therefore it presents maximum number of electrons only 2 into 1 square, that is equal to 2. In second cell present 2 into 2 square, 4 into 2, that is equal 8 electrons. In third cell present 9 into 2, 18 electrons present in third cell. The maximum number of electrons present in an orbital is 2. The maximum number of electrons present in an orbital is 2. Orbit. Orbit, only principal quantum number is required to describe orbit. This orbit described only principal quantum number. This orbital depends on principal quantum number, azimuthal quantum number and magnetic quantum number are required to describe orbitals. Electronic configuration of elements: hydrogen 1s1, helium 1s2, lithium 1s2, 2s1, beryllium 1s2, 2s2, boron 1s2, 2s2, 2p1, carbon 1s2, 2s2, 2p2, nitrogen 1s2, 2s2, 2p3, oxygen 1s2, 2s2, 2p4, fluorine 1s2, 2s2, 2p5. So increasing order of energy levels to distribute the electrons in various available orbitals. Similarly, fluorine, neon 1s2, 2s2, 2p6, sodium 1s2, 2s2, 2p6, 3s1, magnesium 1s2, 2s2, 2p6, 3s2. The increasing order of energy levels from 1s orbital to 2s, then after 2p, 3s, 3p, then after 4s, 3p orbitals. Frequently asked questions. Frequently asked about this topic. Explain about Abbo's principle. Explain about Abbo's principle. Explain about Hund's rule. Explain about Pauli's principle. Draw the shapes of S, P, D orbitals. Write difference between orbit and orbitals. Write difference between orbit and orbitals. Abbo's principle. What is Abbo? Electron enter into lower energetic orbital before enter into higher energetic orbital. Electron enter into lower energetic orbital, then after enter into higher energetic orbital. The principle is useful in calculation of relative energies of different orbitals on the basis of n plus L value. The greater the n plus L value, more will be the energy of orbitals. 4s and 3d. These two different orbital n plus L value is lower value of 4s orbital. These orbital first enter into electron, then after enter into 3d orbital. If the n plus L value is same for two orbitals, the orbital will have lower n value, lower energetic orbital. 4s and 3p orbital. 4s orbital n plus L value is 4, 3p orbital n plus L value also 4. The energy of 3p is less than 4s orbital. The relative energies of orbitals can be also obtained from Euler diagram. Explain about Hund's rule. Whenever degenerate orbitals are available for electrons, the pairing of electrons takes place only after all orbitals filled with one electron each. So, according to Hund's rule, whenever degenerate orbitals are available, nitrogen is present, valence shell 5 electrons. These 5 electrons filled in various available orbitals. Nitrogen p orbital, maximum number of 3 electrons. These 3 electrons filled px 1 electron, py and pz orbitals. According to Pauli's principle, third one, no two electrons in an atom can have same values for 4 quantum numbers. The two electrons in an atom difference in at least one quantum number. The two electrons of different orbitals consider of 2s and 2p orbital. These two electrons, carbon 2p2, n values are same, L values 0, 1, M value 0, minus 1, S values are plus of and plus of. This one is Pauli's principle. Draw the shape of SPD orbital. S orbital in spherical shape, P orbital in dumbbell shape. It have P3 orientation. These three orientation orbitals are Px, Py and Pz orbital. D orbital have 5 orientation. These 5 orbitals are dxy, dyz, dzx, dx square minus y square and dz square orbitals. What are the differences between orbit and orbital? Orbit. It is a circular path of electron around the nucleus. Orbital. It is a region around the nucleus where the finding probability of maximum of electron is called orbital. It is circular in shape. Orbital have different shapes. S orbital in spherical shape, P orbital in dumbbell shape, D orbital in double dumbbell shape. These are different in shape. It is a two-dimensional. It is three-dimensional. Maximum number of electrons present in orbit 2n square. The maximum number of electrons present in orbital is 2. This orbit depends on only principal quantum number n value. Orbital depends in n value, l value, m value and s value. Principal quantum number value n, azimuthal quantum number value l, magnetic quantum number value m and spin quantum number value s. These are differences between orbit and orbital. Thank you once again.